Hello everyone, welcome back to this online class. My name is Francis Okech and my YouTube channel is Professor Francis Okech. Today we are going to look at Calculus 1 and our main topic is on the basic differentiation rules. In particular, we are going to look at the quotient rule. So what does it state? This is the statement of the quotient rule that if y is equals to a quotient u of x divided by v of x, u and v are functions of x, then dy dx will be equal to u prime of x times v of x minus u of x times v prime of x, everything divided by v of x, and the whole of this is supposed to be squared. So this is the quotient rule. Let me bracket it. This is the quotient rule. So when do you apply the quotient rule? When you have a rational function. So this rule is applicable. It is applicable when differentiating a quotient or and differentiating a rational function. Rational function with the numerator and denominator being functions of the independent variable x. So you can say with numerator and denominator being functions of x, where x is the independent variable. So what does the rule states is that you differentiate u keeping v constant minus, now keep u constant, differentiate v, then over v squared. That's the quotient rule. Let us derive it, this rule, derivation. So when deriving it, we are going to say let's write here, let f of x be equal to u of x over v of x. So from here, it means that f of x plus h is the same as u of x plus h over v of x plus h. So I now need the difference of those two functions. So we say therefore f of x plus h minus u, not u, but that should be f of x. F of x plus h minus f of x. What should it give us? This is u of x plus h over v of x plus h minus u of x over v of x. And so here, we need to get the LCM. Our LCM here is v of x plus h times v of x. And then when we work it out, we are going to get u of x plus h times v of x, then minus u of x times v of x plus h. So in the numerator, I am going to add and also subtract a certain function. And the function that I'm going to add and subtract is this one. In the numerator, you need to add and subtract u of x times v of x, so that this can also be written as it is, let me use the color that I was using, u of x plus h times v of x. We are subtracting, it's a minus u of x, v of x. I also add u of x times v of x. Then I can see there was a minus u of x times v of x plus h. And so this one is over. You divide this by v of x plus h times another v of x. Look at what I've written in red. That is the function that I'm subtracting and also adding, so that I can now group this. The first two should form one group, and this other one should form the next group. So this fraction can be simplified to take the form. Look at in the first bracket, v of x is common. So this can be written as u of x plus h minus u of x. And what is common there is v of x. Then the other one, I can factor out because you see, I can see there's u of x common. So I can factor out negative u of x common, so that inside we have v of x plus h minus v of x. I have factored out the negative u of x. Take note of that. So the whole of this is divided by v of x plus h times v of x. Now, using the first principle of differentiation, so we write here using the first principle. What will we get? We have, now we need f prime of x. F prime of x is the same as the limit as h approaches 0 of f of x plus h minus f of x, and the whole of this you divide by h. That is from the first principle. And so we can substitute what we have. In the numerator, we replace with the whole of that. So this can be written as limit as h approaches 0 of u of x plus h minus u of x. This is times v of x minus u of x times v of x plus h minus v of x, and the whole of this is divided by v of x plus h times v of x. That is our numerator, and that numerator should be divided by our denominator, which is h. So it's like multiplying by 1 over h. So times 1 over h, because we are dividing by h. So we have that. Now this thing can also be written as, because you see I can split this limit into two parts. We are distributing the limit. So you split it into two parts. So we are going to get, this is now the limit. The first part is limit as h approaches 0 of u of x plus h minus u of x divided by h Then this one is multiplied by v of x over, before I write over, let me write the other part. The other part is minus limit as h approaches 0 over u of x times v of x plus h minus v of x, and this is divided by h. That's very important. Let me bracket this and also this other one. Also the limit of the denominator, so over the limit as h approaches 0 of v of x plus h times v of, see limit, properties of evaluating limit. Limit, you can distribute it to all those functions. Work out the numerator independently, then the denominator also take the limit as h approaches 0. So, and I told you that anything that does not depend on h, you can be able to factor it out. So this thing can also be written as, we can as well write this as a limit as h approaches 0 of u of x plus h minus u of x. The whole of this is divided by h. Then times v of x. See, that one does not depend on h. Minus, now I can see u of x can be factored out. Then inside we have limit as h approaches 0 of v of x plus h minus v of x. The whole of this is divided by h. And then our denominator should be this one, limit as h approaches 0 of v of x plus h, that one, then times v of x. So now, what do we mean by limit as h approaches 0 of u of x plus h minus u of x divided by h? From the definition of derivatives, that is the same as u prime of x. So this can be written as u prime of x times v of x, then minus u of x. What about the other limit? This is the same as v prime of x over, this other limit is v of x plus 0. We are using direct substitution. And the other one is v of x. You see, v of x plus 0 is the same as v of x. So this thing can as well be written as, it can now be written as u prime of x times v of x minus u of x times v prime of x, everything over v prime, not v prime, but that should be v. So I should write there v of x, and the whole of this is squared. So this completes our proof, and this is the what you are calling quotient rule. So in summary, you see those of x, those ones can confuse somebody. You can simply take note that when you are differentiating a quotient, that is u over v, you need to get u prime v minus u v prime, everything divided by v squared. That is quotient rule in summary. You need to master this formula because you will use it in advanced calculus. So, having derived the formula for the quotient rule, let's see some examples on how to use that rule to find the derivative of y with respect to x. So I'll give you just 2 examples are enough. So I write here examples. You are asked to find dy over dx given that in part A we have y is equals to 2x squared plus 1. This is divided by x squared minus 1. In part B, you are given y is equals to x cubed over x minus 1. So just 2 examples are enough to explain the concept. Let's see how to solve the 2 questions. Solution for part A. We are going to start by saying let the numerator here to be u and denominator to be v. So let u is equals to 2x squared plus 1. And v, remember this is 1, v is equals to x squared minus 1. So therefore, we need to get u prime, use power rule here. That will give us 4x. And v prime will give us 2x. So now dy dx, can use another color, dy dx, it should be equal to u prime v minus u v prime, everything over v squared. If I substitute, I'm going to get 4x as u prime. Our v is x squared minus 1 minus u, which is 2x squared minus 1. No, that's a plus 1. That's u. V prime is 2x. And this should be over v squared, which is x squared minus 1. And this is supposed to be squared. So when you open the bracket in the numerator, we are going to get 4x cubed minus 4x minus another 4x cubed minus 2x. This is over x squared minus 1 squared. And you see now we can simplify. I can see 4x cubed will cancel with the 4x cubed, so that negative 4x and negative 2x, that will give us negative 6x. So in the numerator, we have negative 6x. So this is equals to negative 6x over x squared minus 1 squared. That's our dy dx. Let's see how to go about part B. In part B, now this is our u and this is our v. So you say let u be equal to x cubed and let v be equal to x minus 1. So we need to find u prime. U prime here is equals to 3x squared and v prime is equals to, when you use power rule, we get 1. So now again use the formula quotient rule, dy dx. That should be equal to u prime v minus u v prime, everything over v squared. And so when I substitute u prime, that is 3x squared times v, which is x minus 1, minus u, which is x cubed, times v prime, that is 1, everything over v squared, x minus 1, and this is supposed to be squared. So when you open the bracket in the numerator, we are going to get 3x raised to 3 minus 3x squared, then minus x cubed. This should be divided by x minus 1 raised to 2. We can simplify. You see, 3x cubed minus x cubed, that is 2x cubed. So this should give us 2x cubed minus 3x squared, everything over x minus 1, and this is squared. And you could also write this as x squared common in the numerator. Then we have 2x minus 3 over x minus 1 squared. So that is our dy over dx when we use what we call the quotient rule of differentiation. So just take note that every time you have a rational function where the numerator depends on x and denominator also depends on x, then use quotient rule, which states that the derivative of u over v is equals to u prime times v minus u times v prime, and everything divided by v squared. That is quotient rule. Very easy, as you can see in example part A and part B. So thank you all for watching this video. Please subscribe to my YouTube channel. That is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you will find me right there. When we meet next time, we look at other techniques of differentiation. Bye-bye.